Hello, welcome everybody to this webinar today. Topic is heating solutions with the Ohmpilot and heat pumps. Very pleased to see you here. My name is Hans Pelz. I will guide you through this presentation, which will take about 30 minutes. And in the chat is also my colleague Anthony Moises. He will answer your questions during the presentation and afterwards. So feel free to send your questions. Following topics are on the agenda today. First, I would like to give you a general information about PV to heat, so how we can integrate and combine that two systems, heating system and PV system. Then we look into hot water generation, and then we look into the heating and cooling solution with heat pumps. And finally, also the combination battery storage and heating solution, how you do that in the best way. Last but not least, we'll look into the economics, so how to see your savings, what you can expect when you do that. Before I start, I would like to have a short question to you. And the question is, what's the most common request of your customers at the moment? Is it the integration of heat pumps? Is it the integration of heating rods? Is it the air condition? Or is it a hot water, hot water heat pump solution? If you just click on your most important request from your customer, there is, I guess, only one answer possible. So please click on the one which suits best to you, or it's most important for your customers. Good. I think there is already good feedback. I guess I can close that, and it is about 40% are with the combination with the heating rod. So they see this is most important need from your customers. 20% with the heat pumps, and also air conditioning is about 20%. And some people are also interested in a hot water heat pump solution. Good. We'll look into these solutions later at a later stage. Thank you very much. I'll then continue with some general information about PV to heat integration. Basically, first, this is an average PV production, the yellow curve. You see the months from January to December. In Europe, this is a graph from Europe. We see, of course, the highest production in summertime from April to October. On the other hand, the consumption of heat solutions, or heat pumps in this example, are especially in the winter time, of course. So January, February, and also, of course, November, December, which suits not best to our PV production. So there is, of course, a certain problem here. On the other hand, we see that we can also use, so this is the period where we do heating and where we need in the building heating and hot water, which is with a certain maximum self-consumption possible, but of course limited. On the other hand, the summer period where we need especially hot water and possibly cooling is of course much more important for us, because this can be supported from the PV system quite easily. Special considerations for PV to heat usage is we want to increase the self-sufficiency of our system. We want to reduce full cost for the main heating source. If it's gas heating, oil heating, or pellet heating, wood heating system, we want to reduce and save this as much as possible. We want as well conserve the primary heating system, so we want to increase the lifetime of the main heating system. Then we want also, of course, reduce our emissions. We want to have matched components. Of course, they should be probably from one manufacturer, or be of course, in a way just to support other components. And it should be a safe functionality. So of course it should work properly. The customer should never have the problem with a cold room, cold water because there's no PV power available. And therefore, a good planning with the heating specialist is important, is really necessary in many cases. So this is our first recommendation here. Please get in contact with the heating specialist who did the heating system and try to find out the best way to combine that with your PV system. From Fronius, we offer basically two solutions with our Gen 24 inverters. First, you can, of course, use the SG Ready output of the inverter, which is basically a load management digital I/O 12 volt, which you can use to give a contact to the heat pump. Second solution is a modulating heat pump control via our open interface solar API or Modbus TCP, where you can, of course, read out the data from the inverter. Some heat pumps can do that. I will show you later which ones are here compatible. And the other solution for hot water generation is basically our Fronius Ohmpilot with the heating rod, where we can use surplus energy from PV system to be sent to the heating rod, and we exactly store the hot water then in a hot water tank, buffer tank. Additionally, we have also here a SG Ready contact. So also this one can be used on the Ohmpilot. We have really a relay contact. So there is no additional component required when you use this contact from the Ohmpilot. Of course, combinations is also possible. So you can have the modulating heating control from the Gen 24 as well, using the Fronius Ohmpilot for the hot water generation in summertime. So that's also recommended, and I will give you more details later on. Now, let's start with the hot water generation and the Fronius load management. Basically, I told you we have 4 digital outputs on the inverter, which you can set on the point load management. And you can here give out a digital I/O for the heat pump to produce hot water, or possibly as well to control the air condition. So the air condition could also be started from that relay contact and use the air condition only in the period where we have really high temperatures during daytime, and avoid running time at nighttime. Of course, this is maybe sometimes not appreciated. Some people would like to have the air condition as well running at nighttime, and then I would not switch off the air condition, of course, at nighttime, but use the air condition with a higher power during daytime. So this can be done quite easily. What is SG Ready control? Very quick. We have usually the heat pumps, the hot water heat pumps have an input, 2 inputs actually, where they have on the second one, the so-called heat pump start recommendation. And this, when you give a signal on the second one, closing contact from a relay, the heat pump will go to an increasing temperature. So it will first of all increase the hot water temperature, but also possibly heat up the building for floor heating with 1-2 degrees higher temperature to store at the daytime energy in the floor or in the hot water tank, which you can use then at nighttime. So this is a signal and an input from these heat pumps, specially made for PV systems or for low energy tariffs as well. But we use it here, this example, for our PV system output to control, to give a recommendation signal to the heat pump to tell them, okay, now is enough energy available. You can start now and increase the temperature to use more of the day, and not the running time should be limited at nighttime. So there are also other signals available, which we usually don't use. A stop mode or a start mode It's also possible here with the other relay contacts or inputs. Now to the configuration, what you need to do first, you need to do the wiring from the inverter. We have a 12-volt output, so you need a 12-volt relay with a maximum coil power of 6 watt. And the closing contact then goes to the heat pump. So you need to wire the inverter with 2 wires to the heat pump. And then you need to set in the web interface the load management, first the functions and IOs. So you need to set here, for example, pin 1 to be used for load management. And secondly, in the load management settings, you can set the threshold. So when it should start and when it should stop, actually, as well as a kind of minimum duration period, which we recommend as 15 minutes, 30 minutes minimum running time, because that's better for the heat pump to avoid, the start and stop, which is not good for the compressor of the heat pump. So that can be quite easily be done in the inverter, and also later on I can tell you also with the Ohmpilot how to do that. So when we come now to the Ohmpilot and the hot water generation with the Ohmpilot, the product, we have a maximum 3 kilowatt single phase output or 9 kilowatt 3-phase output on the Ohmpilot. So you can supply it with 3 phase, of course. And with that, we increase significantly the self-consumption up to 60% higher self-consumption with a smaller PV system is possible here. And this is basically a solution which you can just connect to your heating rod in the hot water tank. Take care to have the right heating rod. We have other videos available where you can see which one you need to use exactly. So therefore, take care here. The working principle is that we measure with this Fronius smart meter on the feeding point the surplus energy. This information goes via Modbus RTU or via Wi-Fi signal to the Ohmpilot. Then the Ohmpilot will then produce exactly this or send this power to the heating rod, this 500 watt in this example, and there is no surplus energy then more available. So we use all this energy to the heating rod and send to the heating rod. So it's a stepless control, and what we need in this case is a Gen 24, or it can be also snap inverter with data manager 2, the Fronius smart meter, the feeding point, the Fronius Ohmpilot with a temperature sensor optional. We recommend it to use it because then you see also the temperature in SolarWeb, which is quite good, and the boiler or hot water tank with a heating rod is of course also necessary. So how does it look then in SolarWeb? You see here a cloudy day. Daily production is very limited. We see there is some surplus energy available, which is used on the heating rod. There's also some gray part where the heating rod has switched off, but in general, it's following the production curve or using exactly the surplus energy to increase the temperature. Here we see also an example on a sunny day. On a sunny day, we increase temperature to a higher level. You see the red curve, temperature curve is increasing here from, let's say, around 55 degrees to 60 degrees. And we have possibly here as well a bigger hot water tank to store all this energy, this hot water, in the hot water tank. So the temperature is displayed as well, the energy in red color, which goes to the heating rod. The wiring is also quite simple to do. You see the input on the left-hand side, 1 phase or 3 phase. On the right-hand side, we go to the heating rod. This is a single phase heating rod in this case. If you have a 3 phase, there's in the middle also a connection for L2 and L3. And with the relay contact here, we could also control our SG Ready heat pump in this case. So the normally open contact here from this terminal will be used with 2-wire to the SG Ready input of the heat pump, and this will then additionally produce hot water or do something else or heat up the building, whatever. So in this case, we would also run first of all the Ohmpilot when we have a surplus energy available, and use also here maybe higher temperatures, because the heat pump is usually only working up to 50 degrees very efficiently. If it's getting higher temperatures, it will reduce its efficiency, and then it's also okay to run it with a heating rod possibly. So with a heating rod, we can go up to 60 or even higher temperatures. So therefore, it makes sense to combine that and use this combination. How to do the settings on the Ohmpilot? We set first the single phase heating rod. In this example, it will be measured automatically, so the power will be displayed then, in this case 3 kilowatt. And the heater 2 is our relay contact, which we need in this case for SG Ready heat pump. We then set a certain feed-in threshold, in this case 3000 watt, and a switch off threshold. So this is the power of the heat pump, and the switch off threshold in this case, for example, a small consumption of 500 watt. With that, the contact would come when we have 3 kilowatt surplus energy, and then stop again when there is a consumption of more than 500 watt. What you can also set is a temperature sensor, and with the temperature sensor, you could adjust here certain day times where you would like to have a certain temperature. So with this control, you can make sure that you have your temperature available at this time when the customer is at home, for example, arriving in the evening, and he would like to have his hot water at this time. So if then the temperature would, or if then they would not produce enough temperature from your, let's say, from the PV system in the summertime, then the temperature or the hot water would then be generated from grid power, or also with the heat pump, of course, for example. Now the second part is the connection of the heat pump, and here we have also the cooling part integrated. Basically, what many times happens, that's kind of worst case, heat pumps are not PV optimized. They're running early morning, in the nighttime, and as well in the evening, but at a time when we have no PV power available. So in this case, you see this is on-off heat pump, which is switching on and off all times during daytime, but not using a lot of the PV power. And this, of course, can be avoided in a time that you set the timer of the heat pump, especially, of course, in the summer period, to a later hot water generation, and a later and not too late in the evening hot water generation, maybe 2 times, once in the morning, anywhere 9, 10 o'clock, let's say, and the other one in the afternoon, 4 or 5 p.m., for example. With that, you can avoid as well the running time at night time. So this is also one possibility, the easiest way, let's say. But better is, of course, the SG Ready combination. When we control that from our PV system, we can really say start now, because now we have enough PV power available. And so we will then only use the PV surplus energy. Of course, not 100%. There is also some limitations, because we cannot say exactly when we have now enough PV power that this PV power is also there for the next 15-30 minutes, because the heat pump sometimes run 30 minutes minimum running time, and that would mean that we also consume some power from grid as well. So that's not 100%, of course, from PV system, but it is much better than on the picture before. There's also a white paper available from that. So if you look on the documents, you can find here also I've a link, or this paper is integrated here in this webinar. So feel free to download it here from the documents. The third possibility is the modulating heat pump or inverter heat pump, which is really following when it's connected to the PV system, following the production curve of the PV system. As you can see on the picture below, so we run really according to PV power. There's also some night consumption, but it's very limited in this case. Of course, therefore, we need a compatible heat pump, and we have at the moment following manufacturers available. You can see that on our web page as well. It's IDM, MTech, Bosch, Ökofen, Nibe, and Wolf. And there will be additionally 2 new ones coming up very soon, which you can find then on our web page as well. So feel free, just go to our web page. You will find under compatible third-party provider heat pumps this updated list with an all new heat pumps. Of course, this is the best solution, what you can do, and therefore you just need to bring the inverter online, of course, maybe set the Modbus TCP, switch on the or activate Modbus TCP or Solar API. And also, of course, the heat pump has to be online, also be in the same network. And then you will get the communication from the inverter to the heat pump, and we can, of course, as well control the power and send it to the heat pump whenever needed. Now, what to do with a battery storage combination? With a battery storage combination and heating solution, for example, as we show here, so we have a Gen 24 inverter with a BVD battery, we have the hot water tank, and we have also the heat pump. The heat pump is in this case controlled by SG Ready control from the Ohmpilot. We have the Modbus RTU communication between inverter and smart meter as well. The Ohmpilot is here, wired, connected via this Modbus communication. And now, how is this working? Basically, you need to know, of course, with the battery, you can, of course, avoid this grid consumption, what we have seen before when we have a SG Ready contact. Heat pump is running half an hour. Of course, then when there's no PV power because of a cloud, the power would come from the battery. So you have a higher self-consumption, higher self-sufficiency when you use a battery. This is always actually quite good and a good recommendation, because you avoid here with the SG Ready input the grid consumption, especially in summer period, in winter period. As you know, it is in any way quite hard to do that. This could look like this example here. We have, first of all, this is summertime. Now, let's say we charge in the morning the battery. This is the green color. So all surplus energy goes to the battery. When the battery is fully charged, we send automatically the energy to the Ohmpilot. The Ohmpilot is second priority standard, and then we will produce our hot water, which we need in summertime, for example. Then the third priority would in this case be the load management. In this case, for example, we switch on the air condition or switch on the air condition to a higher, to a lower temperature, so to more power to reduce the room space temperature to a lower temperature. And this is our load management output. Could be as well as SG Ready output to heat up the building in the springtime or in autumn, or maybe to cool down the building with the heat pump in the summer period when it's a hot day. So therefore, you just need to have the right heat pumps. Many heat pumps nowadays can do both the heat and they can heat and cool down the building. So they have both modes integrated, and you can just tell the heat pump in summer period when the outside temperature is higher than, let's say, 30 degrees, the heat pump should run in the cooling mode as well. So that's also possible with the heat pumps. They can do that. Just need the signal, SG Ready signal, and then they cool down the building as well. Of course, you need the right heating system in your building. That's not always possible, but you can theoretically use that as well. So we have 3 priorities, and these 3 priorities can be set in the inverter. So you can say, for example, now load management is more important for me, and you will find under load management priorities the possibility to change here the priority. Or you can also say Ohmpilot is most important for me, and I would like that to have that on number 1. Basically, I would say batteries should be always first, because when you have a full battery, you can run the building in a better way. So you have a higher self autarky or self-sufficiency when you have a fully charged battery in the morning, and you can use that in the afternoon for your heat pump. You can use it at nighttime for whatever you need. So just to tell you that this is possible to be set, and also to tell you, important with the heat, with the actually battery, you are more independent, and also SG Ready contact or SG Ready control gives you more advantage, because you avoid grid consumption, because it's then coming from the battery. So this is here the important point. Good. Last but not least, let's look into the economics. We have 2 reference systems which I would like to show you. So one with out battery, but with the Ohmpilot 7.5 kilowatt system in a smaller house, hot water generation with the Ohmpilot, SG Ready control space heating with the heat pump. In this case, we have a small consumption of the building, so a quite new building, smaller building, 160 square meter, and we have here in this case 5,200 kilowatt hour consumption. With our energy tariff of 30 cents per kilowatt hour average, we get a 1,560 euro electricity bill per year. We have also a small feed-in tariff of 5 euro cents. This gives, as a result, 671 euro savings and 208 euro yield. So for the feed-in, what you feed in to the grid, you will also get a 208 euros per year. That gives in total 879 euro in this case for this 1 year. So quite nice saving, which is from mainly in this case from the heating system, from the heat pump, and from the hot water generation. A second example is with the higher consumption. So we have here 9,950 kilowatt hour consumption, a bigger building with more people, 5 people. So more demand of hot water, more demand for heating. In this case, we get also a electricity bill of 2,985 euro. Same energy tariffs gives savings of, in this case, of 1,580 euro and 95 euro for the feed-in, because there is only a small feed-in in this case, and we get a total savings of 1,677 euro. So this, you can see, is depending on that what you have, how much is your consumption. As higher the consumption, as higher the savings, that's clear. But also it's depending, of course, on the control of the heat pump. So the heat pump autarky can be 50%. It can be also, but only 20%. So if you have a good SG Ready control or modulating heat pump, you can increase that up to 50% autarky. This is a number for average Europe, Middle Europe. Maybe North Europe will be a bit smaller, bit lower, and South Europe will be a bit higher because the heating demand, of course, is lower in that regions. But you see, it makes sense. It is a good number, and of course, good to do that. As a summary, a PV heat integration is usually quite easy to do once you know how to do it. Yeah, but the installation effort is small. So you need maybe one cable from the inverter or from the Ohmpilot to the heat pump, and then of course the settings. The economics, the additional investment for the wiring is small, so you have a good economic. We use our hot water from PV, 6 months minimum per year, can be even more. We have also a longer service lifespan of the primary heating system because we can switch off the primary heating system in summer period, and of course we reduce also the fuel of this heating system. Yes, I already told you, low investment costs, the materials. What you need is usually a smart meter, heating rod, maybe a relay contact for the SG Ready input, and some wires. So that's a small investment, but the amortization can be achieved in a few years only. Optional, what's good is a buffer tank storage, which is of course using the where we can produce a lot of hot water during daytime and store this hot water maybe for day and the next day. So that's also appreciated. Modulating heat pumps are always recommended. Usually the new ones are mainly modulating heat pumps, which you can better control from your PV system. So they have also lower energy power demand at the moment. And a battery storage is also a good combination because then it's also with the SG Ready control quite comfortable, and you use a lot of your energy from your PV system. Good. So this was this information. First, our last but not least, we will send you the recording tomorrow. You can watch that once again. We have also the white paper in here. You can find more on our web page, the manuals and so on from the Ohmpilot, where we have more detailed information about how to install it, how to do that in your case. And of course, our videos on YouTube, how-to videos where we explain the commissioning process in a short way. Good. I would then see the questions, and would like to ask Anthony to come over to me to maybe to answer the most important questions what we have received. Did we?
We did receive questions, yes, and mostly they revolved around the SG Ready contacts. So one of the main questions that was asked was the communication when it comes to SG. Is it possible to determine, for example, the load, how big the load is that you can switch with the SG? So
usually there is no high power on this SG Ready contact. So some heat pumps have a 230 volt signal, but it is with only milliamps. So it's really a small relay contact would be enough for that.
So the bottom line is the SG Ready contact is really only switching a relay. There's no feedback as to what load there is. The only way we can determine the load is by predefining the thresholds, basically, and making sure that we set those thresholds higher than the additional consumption.
Exactly. That's important. So usually, you have on the heat pumps, the power, the maximum power which can occur, and you don't need to, of course, there are two powers on the heat pumps. So one power is the output power, which is of course always higher. We need the power consumption from the heat pump, which is usually around 2 kilowatts, 3 kilowatt, something.
So we set the threshold to trigger the SG signal high enough so that that output, or the used power, is covered by the surplus.
Exactly.
Okay. Exactly. Then there was also a question of, can you optimize that in any way? Can you get the heat pump or also air conditioning? Air conditioning was a major topic. Thank you for the questions, by the way, concerning air conditioning. How can we optimize that with PV? Is there a way of, we mentioned modulating pumps, modulating AC units as well. What do we need for that to work? Because it's not SG. Right?
Exactly. There are also right now SG ready air conditioners available on the market, but they quite seldom. So I would not, maybe we'll see more in the future, because it is an important point. Also, we get the demand from some countries nowadays that air condition maybe has also to be controlled from the grid operator, because we see more and more demand, electricity demand in summer period nowadays. We get really problems already here in Austria with the electricity demand on these hot days. So the energy operator would like to control that as well in a way. So also the air condition will need to have in the future SG ready input for sure. So that would say in the late afternoon when there's too much energy demand, that the grid operator can reduce the power of the air conditioning as well. And this one can also be used, of course, then from our PV system. So we also would then send SG ready signal to the heat pumps and tell the heat pump in the afternoon, now we have enough PV power, run at a higher power, reduce the temperature in the room to 20 degrees, let's say, yeah. And then in the evening when the customer arrives, this is a cold building, and he can then run the air condition with a low power, with a standard minimum power.
Yeah. The other alternative, if people are looking at combining heat pumps and AC, an air-to-air heat pump works very similarly, say, to the AC units, the typical air conditioning units. And there are some modulating models out there that work on API basis. So that's an option. You can use the API calls and use the surplus as it's available.
Exactly.
So the curves match really nicely.
Yeah. So this will be for sure much more important in the future, especially also for commercial buildings, because they have also quite high cooling demand, and they will also, of course, would like to use their PV system as much as possible. So it will also be kind of, for the future, will be also solutions here required, and they will come for sure. So that's already available, but maybe limited for some only.
People are now realizing how important it is. It's going to be on the up and up.
Yes, exactly.
All right, I'll go back to checking for other questions. I'll leave you to finish up.
Perfect. Thank you, Anthony. Great. So good. Then I would like to thank you for your participation. We will close this presentation now, and I will thank you for your say goodbye now. But we stay online with you, so feel free to use the next 10 minutes to send your questions, and we will answer that in writing. Thank you very much, and have a good day. Enjoy your time. Bye-bye.